Intermediate Algebra for Statistics, Using Factoring to Make Predictions with Quadratic Models, Part 3. Lesson objectives: use an equation of a quadratic model to make estimates and predictions. Model projectile motion in the area of rectangular objects. We'll begin with an example. Example 5. The formula P of x equals 0.64x squared minus 0.044x plus 3 models the approximate population in thousands for a species of fish in a local pond x years after 2007. Use a reasonable domain of 0 less than or equal to x less than or equal to 10. Number 1. Is this an increasing or decreasing function? Number 2. What is the resulting range for the given domain? Number 3. How many fish are in the pond in 2007? Number 4. How many fish are in the pond in 2015? Number 5. What is the maximum value over the provided domain? Number 6. Using a graphing calculator, estimate what year the population will reach 40,000 fish. Solution? Number 1. Using our graphing calculator, we type in the model NY1. Using the table feature, we can see values of time and the corresponding population size according to the model. And we want to use the domain from 0 to 10. So as x gets larger, y is increasing also. And it's increasing for the whole interval. To get a picture, we hit window. For the y min, we use -1, so we can see the y-axis. The x max, I'm going to use 11. For the y min, I'm going to use -5, so I can see the x-axis. And for the y max, I'm going to use 75. Now, why am I using 75 is because the largest value that I saw in the table was about 67. So this will be a little bit larger than the biggest y value. Here is the parabola, so we can see from 0 to 10, this is an increasing function. Number 2, what is the resulting range for the given domain? Since this is an increasing function, we can find the value of P of x when x is 0. This will be the smallest value, and then we can find what is P of 10, and this will be the largest y value. And this is because this is a increasing function. So f of 0, we substitute the values of 0 in for x and follow the order of operations, and we get a value of 3. P of 10 turns out to be 66.56. So we say the range is between 3,000 and 66.56 thousand. Number 3, how many fish are in the pond in 2007? Well, 2007 corresponds to x being equal to 0, and we found that value to be 3. So there's 3,000 fish according to the model in 2007. Number 4, how many fish are in the pond in 2015? This corresponds to 8 years beyond 2007, so that means x is 8. Substituting 8 into the model, we have the output of 43.608. So we'd say, according to the model, in the year 2015, the population of fish in the pond will be about 43.6 thousand. Number 5, what is the maximum value for the given domain? That would be when x is equal to 10, and this has been computed before. We have 66.56. We can verify this by using the graphing calculator. If we hit second and trace, which is calculate, go to value, the calculator will give us our graph, then we type in 10, and it gives the corresponding y value. So this is another way that we can find an output for a given input. And number 6, using a graphing calculator, estimate what year the population will reach 40,000 fish. So now we are given a y value, an output, and we want to find what is the input that corresponds to the output. Since the units of fish are in the thousands, our output will be 40. So using the table, we can see that it's somewhere between year 7 and year 8. So if we hit second and window, which is table set, we can start the table at 7 and then count by 0.1. So we see at about 7.6, y will be about 40. So we would say, according to the model, in about 7.5 years after 2007, or about halfway in year 2014, the population of fish in the pond will reach 40,000. Example 6. The number of children with autism who are enrolled in special education classes has increased greatly in recent years. See Table 7. Let n be the number in thousands of special education students with autism at t years since 1995. A linear model of the situation is n equals L of t equals 12t plus 14. A quadratic model of the situation is n equals q of t, which equals t squared plus 4t plus 22. A. Use a graphing calculator to draw the graphs of both models and, in the same viewing window, the scattergram of the data. Which model describes the situation better? So our first step is to enter the data in List 1 and List 2. Here we have the years since 1995, and here we have the number of special education students with autism in the thousands. The next step, we hit second y equals, which is stat plot. We turn it on, and we hit zoom and number 9 for zoom stat. So here we have the scattergram. Next, we need to put the models in to y1 and y2. So y1, I will put the linear model, 12x plus 14, and y2, I put in the quadratic model, x squared plus 4x plus 22. Next, you hit graph, and if we look closely, we can see that the quadratic is doing a better job of modeling the pattern of the data than the linear model. So to answer A, the quadratic model is better. B. Use the zoom out on the graphing calculator to help you determine which model predicts the larger number of special education students with autism for the years between 2003 and 2015. Using the zoom out, we see that the quadratic will predict the larger number of special ed students. To verify this, we can use the table feature. When x is 8, that's the year 2003, we see that y2, the quadratic, is larger than y1, the linear model. For 2015, that's when x is 20, and we see y2 again is larger than y1, the linear model. C. Predict the number of special education students with autism in the year 2013. We substitute 18 for t, square first, then multiply, then add, and we get 418. To verify this using the graphing calculator, when x is 18, we see that the model is 418. So in the terms of this problem, according to the model in 2013, there'll be 418,000 special education students with autism. D. Estimate when there were 43,000 special education students with autism. So this time we're given an output, 43, and we want to find the time. So our first step is to subtract 43 to both sides. So the left-hand side of the equation will become 0. Combining like terms, we get c to be a negative 21. So we have our trinomial here that we'll try to factor. What two numbers multiply to give me a negative 21, and at the same time will sum to be a positive 4. Since c is negative, the two factors will have opposite signs. So it turns out that positive 7 and negative 3, have a product of negative 21, and have a sum of positive 4. Setting both equal to 0, we see that t is negative 7, or t equals 3. We can verify this using our calculator. When x is 3, y2 is 43, and when we check for negative 7, we will also get 43. So what does this mean in the terms of the problem? This means 7 years before 1995, there were 43,000 special education students with autism, and 3 years after 1995, or 1998, there were 43,000 special education students with autism. Thanks for watching.